Welcome to the Compliance Assurance Associates Smoke School. In this video, we will discuss the Emission Point, Emission Description, and Environmental Conditions sections of the VEO form. The Emission Point section documents the spatial relationship between the emission source and the observer's position. For valid observations, the sun must remain within a 140-degree sector behind the observer, accounting for both horizontal and vertical positions. Height and vertical angle measurements determine the observer's line of sight, which should be approximately perpendicular, 18 degrees or less. Throughout the form, write down both start and end conditions in the designated fields, even if no changes occur. These fields are particularly important when documenting changes during the observation period, such as an increasing rock pile height, or when the observer must relocate due to shifting winds. Describe the emission point with enough detail to uniquely identify it among other facility sources. Include specific physical characteristics such as the stack type, its visual appearance, and its location within the site, relative to other landmarks. The emission point height is measured from its foundation base. This information is typically found in agency files, engineering drawings, or National Emissions Data System (NEDS) records. At times, it may be more convenient to estimate the height above ground level and the height relative to the observer, such as when the stack is on a roof where the observer is standing. Estimate the height of the emission outlet relative to your position as an observer. This relative height will differ from the emission point's actual height when the observer and stack are at different elevations. Record the distance between your observation position and the emission point. This distance should be approximately 3 times the stack height relative to your position as the observer. Record the direction to the stack using the 8-point compass: north, northeast, east, southeast, etc. When recording direction, indicate whether you are using true north, plant north, or magnetic north. The vertical viewing angle measures the tilt of your line of sight through the plume at your observation point, expressed in degrees. An inclinometer can help measure this angle more accurately. But if you are 3 stack heights relative to you away, this would be 18 degrees. It is helpful to have both measurements. Keep this angle at 18 degrees or less. If the angle exceeds 18 degrees, a slant angle correction should be considered. Reach out to your manager or CAA if you need assistance with slant angle correction. The direction to your observation point typically aligns with the direction to the emission outlet, unless there is a steam plume present or the most dense portion of the plume is offset from the emission outlet. When the point of observation is offset from the emission outlet, record both distance and direction relative to the emission point using specific measurements. For example, 10 feet above and 100 feet east of the outlet. Document the emission's physical characteristics, behavior, and any visibility issues or obstructions. Describe both the plume color and background to establish contrast level, and include water droplet details to fully characterize the plume. Record conditions at both start and end of the observation period. Document any changes in the comments section. In the Emission Description section, document the plume's characteristics such as texture, gradation, and shape, including patterns like coning and fanning. These plume patterns correlate with specific weather conditions. Record any changes in plume characteristics during the observation period in the adjacent comment space. The emission's color helps identify its composition and determines contrast for opacity measurements. Record the initial color and document any changes that occur during observations in the data table's comment fields. Document water droplet plumes whenever steam or visible water droplets are present, though readings are preferable during periods without steam plumes. Water vapor plumes are excluded from emission measurements. They appear as white, billowy formations similar to clouds and will collapse as the water droplets evaporate into the air depending on humidity conditions. However, in some conditions, water vapor will appear translucent. Our self-paced lecture contains additional detailed information and videos for helping you identify water vapor. Due to the complexity of identifying water vapor plumes, new observers should consult their manager or CAA if they need assistance. Record environmental conditions at both the start and end of your VEO observations as weather effects readings. Most fields in this section require both initial and final readings to track any changes. While smartphones can provide weather data, document the actual conditions you observe at your location. Local conditions may differ from general weather reports, and this form requires your direct observations. Document what appears behind the plume, such as trees, sky, or buildings, as the plume background. Select an observation position that provides a high contrast between the plume and its background whenever possible. Record the specific background color using descriptive terms like light green, sky blue, or gray clouds. Greater detail provides more confidence in the observation documentation. Document cloud cover as a percentage of the entire sky using these categories: clear, less than 10% coverage; scattered, 10 to 50% coverage; broken, 50 to 90% coverage; overcast, greater than 90% coverage. Record both the extent of cloud cover and the color of any clouds. Include cloud color in the comments section. Use these only specific percentage-based categories rather than general terms like partly cloudy or mostly sunny, which have no specific meaning in regard to the current amount of cloud cover. You can determine wind speed in several ways: by checking your cell phone weather data, by using the Beaufort scale covered in the CAA lecture course, or by taking measurements with an anemometer. Document wind direction using the 8 compass points based on where the wind originates. Following EPA guidelines, record the direction the wind is blowing from, not toward. For example, a north wind travels from north to south. If the plume is visible, you can determine wind direction by observing the plume's movement at its emission point, not your observation point. Alternatively, you can reference wind direction from your cell phone's weather information. Specify the outdoor temperature at the site and indicate whether you are using Fahrenheit or Celsius. Check your mobile device's weather information to determine relative humidity. This measurement is especially important when observing sources that may contain condensed water vapor. While you can measure relative humidity with a sling psychrometer, most observers rely on weather apps for this data. Continue watching this video series for instructions on completing the entire VEO observation form.